Finding the inverse of the function is something that you're going to have to know for not only this class, but for all your future classes in math. So there's a basic notation that is slightly different than what you've been used to, but it is not going to be that far-fetched that it's hard to understand. It's just something new that you're just learning, okay? Original function is f of x equals 3x plus 2. And what did I say about f of x being? Is that same as what from our past? No, let's try that again. What is it equal to?
0.
It's equal to y. F of x is same as y, right? So, still doesn't want to work? Come on. I don't know. I'm going to plug it in and hope that it'll be okay later. I'm going to use this one for now and see if that works better. Okay. So replace f of x with y. Okay. First step, we replace f of x with y. Then it would look like y equals 3 times x plus 2. So it turns out to be y equals 3x plus 2. Okay. Second step, you're going to inverse the x and y values. This is what that means. Inverse the x and y values, which means you're swapping them. Switch where the x is with y and switch where the y is with x. Okay? So we're switching out y with, what just happened? Stop moving. X equals 3y plus 2. Any questions on what we just did? We swap out the x and y's, moving them around. And then we're going to solve for y. Okay? When we solve for y, what happens is that we end up using inverse operation to get y by itself. Okay? We're isolating the y, so here it is. I have my x equals 3y plus 2. I'm going to subtract 2 first. Then I have x minus 2 equals to 3y. And then we have y still with 3, so we're going to divide both sides by 3. And boom, we have our new inverse function. And instead of writing y equals, we write, watch this, it's f to the negative first power of x. That means inverse of, this is how we read it, inverse of f of x is how we read it when you see this negative first power. I need this to move down. Here. Sorry about that. The way we read that green is inverse of f of x. We're replacing our previous y with that notation. And we have x minus 2 over 3. Okay? This is called the inverse function. Now, I want to show you really quickly on Desmos what it looks like when you have inverses of each other. The original was f of x equals 3x plus 2. Okay? So it's a line, right? It's a linear. Let's see what happens. If I do another line, put it in as y or f of x. There you go. Now, watch this. The original's the red, right? What's the ordered pair for that y-intercept? Or the y-intercept?
I mean 2.
Try again. What is it?
2.
Ordered pair for the y-intercept.
2, 0.
Try it again.
0, 2.
0, 2. Okay, we're back. Okay. 0, 2. 0 is the x. Y is the 2. What's the inverse is x-intercept? 2, 0. It's not the y-intercept, it's the x-intercept, right? Okay, what else? What's the x-intercept for the original function? -1, no, negative like 3/4 maybe? 0. And then the y-intercept, 0, negative 3/4, right? Do you see how they switch the places of the order pairs? Okay? That's a very automatic thing that happens with inverses. So when you see a relationship like this, you automatically know they're inverse functions. Okay? You're going to be asked to graph. Desmos is going to be your best friend unless you use your graphing calculator. I'm not about to teach you how to use the graphing calculator today. Okay? I'm trying to save my voice for the main lesson. So let's go back here. Let's take a look. Okay? Here it is. Okay. So we're going to fill in the f of x and g of x values in the table. The only thing that f of x and g of x, the difference is that they're different functions. Just like you guys have all different names, but you guys are all humans, yes? There's nobody here that's like a werewolf or a vampire or anyone that is not of the same species, yes? We are all the same. Even though we have different equations, we have different names for those equations. F of x, g of x. That's all it means. Does that make sense? Okay? So, f of x is right here. Oops, I accidentally pressed that. F of x. F of x is right here as well in our graph. Okay? So, at -7, here's -7. What is my y value right there? -3. Fill it out. Okay? -1. And then 1. 3. 3, 2. And then 5 is going to be, is that 3? 3. Okay. What do you think is going to be the g of x results for all of those x values that we have there? Okay, you're not sure? Let's find out. Here we go, red. I'm doing the g of x, right here. -3, where's -3? There it is, -3. I'm gonna go straight down. It looks like -7 is 5. What do you notice? It's the same table, but it's flipped. It's the inverse. Okay? This is what we call an inverse table. Okay? Inverse function table right here. Only using the table, identify the following. What are the domains of f of x? X values. What does it range from? Parentheses, -7, comma -1, comma 1, comma 3, comma 5. Those are my domains. The reason I'm listing it is because it's broken up in terms of the list that we were given. Okay? We already know it's continuous because we have a graph to go with it, but we're going to just list what is based on the table, only using the table. Okay? G of x, -7, -1, 1, 3, and 5. Would you look at that? They're identical. What about range of f of x? What's the range of f of x? -3, 0, 1, 2, and 3. G of x, domain of g of x, -3, 0, 1, 2, and 3. Do the two lines reflect over y equals x? Oh, you're not sure what that means? This is from geometry, people. Algebra 1 in geometry. I know you did transformation in Algebra 1. I know you did transformation with Mr. Siddell. So here is the mirror at y equals x. That's just a straight line that goes to the origin with the slope of 1, right? This is y equals x. Does it reflect? A mirror reflection. It does. So yes. Do the two lines reflect over y equals x? Yes. True reflection. Okay. Plot for B. -6, 0, -2, 2, 0, 3, 4, 5, and 6, 6. And then I want you to try to figure out what the g of x's ordered pairs would be. Okay? Negative 6, 0. So I'll do f of x again in green. 2, 2, 0, 3, 5, 6, 6. Where's my ruler? That There's my f of x. Label. Label, label, label. Okay? G of x. Remember what happened with the domain and range? What do we do? Switch them. So what would this be? Negative 6, 0 be in G of x. Zero, negative 6, 0, negative 6. Okay, and then it'd be 2, negative 2. What would be the next one? Looks better. G of x. Okay. So we did this. We swapped the x and y values of f of x to write g of x. We graph the order pairs and draw the lines for each function. Do the two lines reflect over y equals x? Yes. So far so good. Our inverse lines, reflections of each other. I can easily make a conclusion with A and B evidence that inverse operations that are lines are reflected over y equals x. Okay? All right, C. How do we find function g? We're going to try to find, I think it meant to find an equation. For function g, switch the x and y values in function f and solve for y. So let's swap the x and y like we did on the anchor chart. What would that look like then? The y and the x get swapped, so I have x and y. Let's do this right. Equals 3 plus 6, like that. Yeah? How do we solve for y? Inverse operations. Subtract 6 on both sides. X minus 6 equals 3y, divided by 3. So I'm going to have y equals x minus 6 over 3, which is the same thing as g of x, right? I'm going to graph this one first. Begin with the b, move with the m. We begin with 6. We're going to move with the slope. Up 3 to the right 1 can't happen, so which way do I go? If I can't go up 3 to the right 1, what's the very opposite of it? Down 3 to the left 1. 1, 2, 3 to the left 1. 1, 2, 3 to the left. Okay. You want to draw your lines all the way through the whole grid so you can see the full reflection. If you draw it too small, it won't look too much like a reflection. It just looks like a snippet of some sort of a weird picture. I'm going to graph this one. How does this look? First, second, third. What's the exponent on the x? 1. Then it's a line. Let's separate it out. If I were to separate this fraction, gigantic fraction, to x over 3 minus 6 over 3, can I simplify that? then this would be y equals 1/3 x minus 2. Now, can you graph it? There you go, -2. And instead of going up 3, we're going to go up 1 to the right, 3, up. Does it look like a reflection? It's looking pretty good. Your line should reflect over the line y equals x. It does. Okay? Identify the following points. It's asking, hey, what y value do you have? -1, f of -1. We're looking at f. Which one is that? Green or red line? Green. -1 is the x value. What's my y value there? 1, 3. -1, 3 is so 3. That's how you decide. Okay? When it's asking you f of -1 equals what? It's asking you what's the y value? What's the outcome when you plug in x for -1? Okay? G of 3? G is the red line, right? So we're going to look for 3 on the x, and it looks like it's -1. Questions? All right. We're learning a lot today. That's evaluating by using graph. That's the same way that you would evaluate if you had just the equation. You plug in that value for x and you solve for y. Okay? All right, graph f of x and graph of g of x is there. Okay, graph of f of x. Does the graph pass the vertical line test? What's the vertical line test? Okay, it's like having those, you guys all have taken Mr. Jones's class yet? Or are you guys in it right now? No, not yet? Next year? Okay. You guys have seen, have you guys ever done, video editing on, iMovie and stuff? You know how, it has a bar that follows and tracks where you are with the music and song and video? The same idea, we're doing a vertical line test. We're trying to see how many times does it hit more than once. Okay? Does it hit anywhere more than once if I were to drag this lovely line across the whole thing? If I keep moving this along, does it hit more than once? Is there more than one video or song or sound? Nope. Then that passes it. Okay? So this is a yes. Okay? We're going to sketch a graph of f of x that reflects over the line y equals x. Identify if it passes the vertical line test. All right. So I know it's going to be tricky, but hang in there, okay? I'm going to try my best to walk you through. We're going to start with the vertex. Where's the vertex here? Where's the vertex of that f of x? 0, 0. It's going to be the same or different for the inverse? Same. So I'm going to put my red dot, right? Superimpose it right on top. Okay? And then I'm going to figure out, okay, let's see. What's my point here for f of x? 2, 1. Swap it and plot it. 1, 2. 1, 2. Okay? So far, so good? Let's find another one on the right, on the f of x. Okay? Let's try this one. Or no, let's try this one. That one's the next lattice point. It looks like 4, 3. Swap it, plot it. Where do I plot it? 3, 4. So here's 3, here's 4. And then this one, 5, 5 is going to remain the same. Do you think this is gonna be passing the vertical line test? It looks like the right side of my original is now my top side of the inverse. So where would my left side end up being? On the bottom, right? So let's try it. What's the ordered pair here? -2, 1, right? Then what's the order pair for the inverse? Is it gonna pass the vertical line test? Nope. If I were to take this vertical line and drag it across, it's never going to be by itself. There's always gonna be someone else in that line, right? So it's like having a duet going on here, some sort, okay? So, let me see. Does it pass the vertical line test after we graph the inverse? No. The inverse did not pass it, okay? The reflection does not pass the vertical line test. Graph g of x. If we graph g of x here, will it pass the vertical line test? It's a single line, yes? Okay, so let's try it. If I were to just go with the original, here's my vertical line. Okay, here's my vertical line. Let's test it out. Does this pass it? If I were to move this along the line, is it going to pass the vertical line test? Anyone confused that there's a dotted line and Ms. Byun keeps saying it passes the vertical line test? We're okay. Okay, vertical line should only look at the solid line. The dashed line should not be considered to be part of the system. It's literally invisible. We have to make it visible for your sake. Okay? So as students of understanding what invisible lines lie, where they lie, we draw in like dashed lines. Okay? Those are invisible lines. If I were to continue moving this back and forth, this is going to pass the vertical line test because it's only going to hit once every time. Okay? If I were to draw an inverse of that, would it pass the vertical line test? That's what it's asking. Okay? So does the graph pass the vertical line test? Yes. It does pass it. But if I were to graph the g of x, would it pass it? It's questionable. Let's see. Here's the f of x, g of x. Okay. That looks like -7, 2. What's the inverse of -7, 2? 2, -7? Yeah? 2, -7 will be the inverse point. Where's another lattice point I can use? Yeah, so can you give me that lattice point for me? You got it. So what would be the inverse of that lattice point? If this is 0, 3, what's the lattice? What's the inverse's point? Okay, so we got cut off a little bit, but it's okay. I'm gonna go ahead and that up. So we were graphing our g of x, right? We got the lattice point. Romeo told us that it was at 0, 3. 0, 3. Come on. No? It looks like a face in there. It won't let me draw. Can I do that? Yep. And then the inverse of that would be 3, 0. There it is. 7, 2, 7, -7. Okay. And then okay. Then the new one's going to be 4, 7. That looks good to me. Is this going to pass the vertical line test? Alright. This is my g of x. Inverse of g of x is g prime, or g, sorry, inverse of g of x. It's written like so. Does it pass the VLT, the vertical line test at the beginning? Yes, it did. And then did it pass after we graphed the inverse of it? Yes. How come it works for line but not for the parabola? I'm not asking a trick question. It's like a very obvious one. How come the vertical line test? It's a straight line. Because it's a straight line, it's going to pass the vertical line test whether you have an inverse or if you have just the original. Okay? Let f of x equals 5x minus 3 and g of x equal 1/5 x plus 3/5. Okay, so there's two functions, right? They're inverse functions. It tells you that they're inverse functions. So this is what I used to learn as Goff and Fogg. Goff and Fogg. Do you know what this is, what I'm holding? This is called a matryoshka. Should I record with the video? So, what I'm holding is a matryoshka. My dad got this for me from Russia. Do you see it? My matryoshka is a mommy nested within another mommy, within another mommy, within another mommy. That's why the matryoshka is saying little mama. Okay? So, I'm nesting a function within a function. I'm taking the x of an original function on the outside and putting the second function inside. Okay? By the way, there's 10 of them. Teeny tiny one in the middle. Okay? I'll show you later. Alright, so we're going to take f of x, which is 5, and then make a big empty gap with parentheses for the x, and then minus 3. This is saying nest the g into f. Okay? Don't worry about it. 1/5. I am so sorry, guys. X goes in place of the original function's x. I nested a function within a function. Does that make sense? So 5, we're going to distribute the 5 to each of those, and we get 5 times 1/5 is 1x. Oh, there goes my matryoshka heads. Plus 3 over 5 times 5 is 3. Then I have my minus 3. And we get x. And that's it, right? 3 and negative 3 cancels each other out, right? So f of g, Fogg, that's what I used to say, Fogg is going to be equal to x. So let's try another one, okay? G of f. G of f means that I'm taking this function as the outside function and nesting the 5x minus 3 into the function of g, okay? So 1/5 plus 3/5. Make a big empty space with parentheses for the f of x to fit in. I'm gonna use, should I use red or green? I'll use green for f of x to be nested in. 5x minus 3. I know you're going to freak out that there's fractions, but it's not going to be hard. 1/5 times 5 is 1x. Okay. 1/5 times negative 3. Yeah, 3 over 5. Plus 3/5. Okay. These two are going to cancel out, leaving me with Goff being equal to x. Any bold souls want to take a stab at why, what that could infer to? How does that make that connection? f of x equals 2x plus 10. Step 1, to find g of x. Switch the x and y values in f of x. So what's asking is that g of x is supposed to be inverse of f of x, okay? So I'm going to switch what normally would be y equals 2x plus 10. What am I switching around? The x and the y are now going to be switched, where x is taking place of y and y is taking place of x. And then now we're going to solve for y. So when we do that, it's x minus 10 equals 2y. And divide everybody by 2. Then I have g of x equals to x minus 10 over 2. Or we can say g of x equals 2, and then I split the fractions. 1/2 x minus 10 divided by 2 is 5. You can have either of these and it'd be correct. Okay? But you have to decide which one you're going to use in your functions when they're asking you to find f of g and g of f. Goff and Bob. Okay? Ready? Which one's nesting inside of which one? For f of g. What do I replace the x for? G is being nested or G is being the mama? Nested. So G of x is written right here. Which one do you want to use? A or B? You want to use A? It doesn't matter which one you use, they're the same. So B? How do I get B or G? B, I split them up. If I split this one, it becomes 1/2 x. And then if I split this one, I get negative. Doesn't matter. I'll use A, and you can see how it goes. Okay, f of x is 2, open parentheses, a big one, plus 10, and I'm going to place in my g of x, x minus 10. F of g equals 2 times the quantity of x minus 10. When we do that, we can simplify the denominators. And I end up with x minus 10, sorry for the bad handwriting, plus 10, these two cancel, and I end up with x. So far so good? Okay, what else? G of f. How do we do g of f? Into g. What's g? Which one should we use for g? You use the b version? Okay, so let's use the b version. It really doesn't matter which one you use. It ends up being the same thing. Sorry, let me change that to red. 1. Nope. How come it does that? Someone make sense of red one note for me. 1/2 minus 5, plugging in 2x plus 10. Then I have x plus half of 10 is 5. Then I will subtract the 5 and combine like terms. And I end up with g of f being x. What can we conclude? What happens when they're inverses of each other that are being next? What do we get? X. X is always going to be the answer if they're inverses of each other. Okay? If they're inverses of each other, you should have x as your result for, this is called compound functions. Result in y equals x. Where's that y equals x from? Nobody yet? Remember that dotted line that goes to the origin and goes up one to the right one? Axis of symmetry for this one is not exactly axis of symmetry because it's not one function. We're looking at two different functions. It's a line of reflection. Okay? Does that make sense? If you have a line of reflection, then the compound functions of those two are going to be inverse of each other. Okay? All right, final thoughts. Here we go. Two functions, f and g, that undo each other because we call them inverse functions, are called inverse functions. Please fill in the missing information to make true statements about inverse functions. So, the inverse of a function blank the members of the order pairs of the original function. What do? Switches or swaps. It doesn't matter which word you use. As long as you don't say opposite. Why is it not opposite? Exactly. It will be the opposite sign if you say opposite. We're not talking about opposite sign. We're talking about literally swapping x and y and y and x. Okay? So, switches or swaps the members of the order pairs of the original function. The domain of the original function is the blank of the inverse function. There you go, range. And vice versa, the range of the original function is the domain. Sorry about the mic. Inverse function reflects over the line. What line does it reflect over? What is the line of reflection? Y equals x. In section D, conduct the horizontal line test on the original function. If vertical line test goes up and down, what's horizontal line test? If vertical line test goes up and down, what's the horizontal line test? Left and right. If I were to use this, would it pass the horizontal line test? The original won't pass the horizontal line test, but what about the inverse? Would it pass it? Yes. Okay. The original function will not pass the horizontal line test, but it will pass, but its inverse, sorry, its inverse will pass oh my gosh, I hate this thing so much right now. And then the converse will be if it passes the vertical line test for the original, Does it pass for the inverse? Vertical line test for original? Will it pass the vertical line test for the inverse? No. Okay. When inverse functions are plugged into each other, composite functions, the result is, what's the result? I just said it not too long ago. What's the result? X. Okay? The inverse function f of x can also be denoted as f to the negative first power of x. Okay? You are going to do homework. Number 1 and 2 is a must. Too easy, that's why. Pick one from 3 and 4. This one. Pick one between these two. And pick one between these two. Then on the second page, pick a column. Which way is a column? Up and down or right and left? Right? No, that's rows. So I'm asking you to choose one of these columns. This is column 1. And here's column 2. Okay? So pick a column. You can pick column A or column, how bad, undo. Column B. Okay, choose either one, but you're doing all 3. So that's 3, then that would be total of 8, right? I asked for a minimum of 8 questions. But because you guys don't have anything going on Thursday, this should be okay to do. Come on, I'm dying here. Minimum of 8 questions. Okay?